Find P, the present value or the initial deposit. In this problem, we are provided a cash flow diagram, which includes a positive cash flow at the beginning of the first year and a negative cash flow at the end of the first 4 years. The cash flow at the end of the first year equals negative $180, and the cash flow at subsequent years equals an 8% increase from the previous year. The nominal interest rate, I, equals 5%, which is compounded every month. In this problem, we want to calculate how much we should be investing at the beginning of the first year to cover the expenses at the end of the first 4 years. We'll begin by noticing the 4 expenses follow a geometric gradient. This is different than a linear gradient because the expenses at the end of each year is 8% greater than the expense of the previous year, which means G equals 0.08. Therefore, it is possible to calculate all 4 negative cash flows based on the cash flow from the previous year. However, for larger problems of this sort, the present value, P, is more easily calculated using this equation, which involves the variables A, G, N, and I. In this equation, A equals the first cash flow in the series, F1, which is provided in the problem statement as negative $180. After this substitution, there will be 2 negative symbols, which means P will be positive, because the second term in the product is also positive. If we were trying to find an equivalent present value P, we would eliminate the negative symbol at the beginning of the equation. Besides variable F1, we also know the value of variable G, which we determined to be 0.08. Variable N represents the number of years, which equals 4. In this equation, I represents the effective annual interest rate, so we'll add the subscript EFF to these terms. The effective interest rate equals 1 plus I over m all raised to the m, where I represents the nominal interest rate, which we were provided, and m equals the number of times per year compounding takes place. Since the problem states the interest is compounded monthly, we know our value for m equals 12, for 12 times per year. Now we can calculate the effective interest rate, which equals 5.12%. Next, we can compute the present value of P. After plugging in variables F1, G, N, and the effective interest rate, the present value, P, equals $713.60. When reviewing the possible solutions, the answer is C.